Hello, hello, hey guys. This is my first stream in YouTube. I think I'm audible. Let me check. Mm, okay, now it's fine. So I'll be communicating in English to improve my English. So, so I'm gonna solve graph. Uh, I think I should add a background music. Wait a minute. Settings, background music. I guess it's not too much volume. Okay. So I will be telling you the graph, what I'm thinking, what the solution I am approaching for. That's how we gonna start. Where is graph? Yeah, here it is. Like we are gonna solve number of enclaves, flat fill implementation multi-source. That's a multi-source solution for BFS. Guess number of enclaves. So you are given an m cross n binary matrix grid where 0 represents a C cell and 1 represents a land cell, which means 3 by m cross n binary matrix where 0 represents a C cell and 1 represents a land cell. Okay, that where 0 is the water and 1 represents the land. A move consists of walking from one land to another adjacent 4 directionally. Okay, so we can move up in 4 direction, the four direction, up, down, and right and left. Or walking of the boundary of the grid. Okay, return the number of land cells in grid. Number of land cells for which we cannot walk of the boundary of the grid. Walk of the boundary of the grid in any number of moves. Cannot walk of the boundaries of the right number of moves. Okay, so this is a grid. Its output is 3 because from these 3 we can't go outside the boundaries like here. You have to be on the edges to play it on the boundaries. No, but not edges. Like if you have here one, then you can go off the boundaries from you. If you start from any of these positions, then you can be able to walk off. But that this is not the connected through any 4 direction, up, down, and close. So that's so therefore we only have these three positions where we can walk. Like here, this is a example. Like in all these 4 directions, if positions, we can walk of the boundaries of the m cross n matrix grid. Okay, cool. All is all ones are either boundary or can reach the boundary. So what we can do here is that so okay. How can we take a pen to the second screen? Okay, so I'm gonna write on my notebook how we are gonna put. And 20 number of enclaves. So I'm thinking of solution. If we take all the edges in consideration, like here we have 1, so we check all the edges from the grid. Like if we check these edges and found any block that have 1, then there will be a position. After that, there is possibilities of getting out of the boundaries from the grid. If you don't have any 1 at the edge, then there is no way you can go out of the boundary. Like if you have zeros on all the sides, so what we're gonna do is that if we think the solution that take these edges and traverse through all the edges from the grid position from all the 4 direction. If one encounter any 1 in all the 4 direction, then we can go again, then here, and until then we encounter a 0. So if we come here and then we can start the traversing or getting the 0. So we can take any of the positions. Okay, so first we have to, so what we are gonna do is that I'll write something. First we gonna traverse all the edges and find out the ones there. If there is any one, then we can traverse. I think what it was in all 4. It can be 3 because if you are an edge, you can traverse only in 3 direction, but we can exclude while we test for the out of the boundary by checking the edge cases. We traverse in 4 direction and go until we find the 0. Okay, that's gonna be the solution. It's just similar to the previous question in the graph series, I guess. So what we're gonna do is that first get the size of the grid, int n grid dot size what this is for grid dot size for column. We have now got size of the rows and column. Now we can go with the DFS. There is a smaller which can no. So like now we can check for row check for the ones on the row 1 and row last, means first and last row. Check for the rows first and last. So you can check the conditions for grid, like if we are in the grid I and 0 for row, because like this, gonna check for the this area. So okay, first we can check for first column, so we can first column, last column. If we found the one, then what we gonna do is that we send that location to DFS, and then we perform all the depth first search on that position, I think. Like it's similar to the solution we have done previously for the surrounded regions. Let me check the syntax. Like here, for that, this is it, like that. If you found here we have found in 0, then we can calling for the DFS, and if they for the left row, and then we can check similar to the that, and then we can check all the condition here. Okay, I'm going right, I think. Great. If we found a okay. Let me check. We can check for if there's no row. Then there is no need for that, I think. First we give the grid, like first I, then 0th location, and grid and the size. Let's see if we find a grid. For grid, last grid, and managed one, and for a row, no, here we have the ith, and here we can get and it's 1, give DFS to DFS the ith m minus 1 comma grid m layers m and then we check similar for the the last and first column. Here we can take from M. Grid will be from 0 to z value, and grid here is n minus 1 to starting from ith, and here we have 4 row. First we are starting from row 0, z, grid m, n. Not n, n. Comma n and m, comma n. Here we can give the arguments like starting from the I. We are now taking these. Then last row is n minus 1, and the ith and grid n comma n. It is the only for the condition. Now we can declare the DFS. So okay, here we can take the vector and on the row and the column. We can use the count for the count. Here we can get the first for the first position. Like we are starting from the first, we have to take all these in consideration from where we are getting the ones, and every time we walk on the another grid position, then it can increase by 1. Okay, and now we check the condition for the boundaries that we are gonna test for. Like first is that I should be less than or greater than less than equals to n less than n. Means row. Less than colon greater than equals to zero. No, we are testing for the if the bound is out of like it's less than or greater than. Okay, which means we have to this for the rejection. So this the condition will it be true, but we have to check for the I. If I becomes less than 0, then it is not is written j less than 0. And the ith becomes greater than equal to the row, and j becomes greater than equal to column. And the last one for if grid it what give me a minute. Okay, so grid is 0, then it will return as it is I comma j double equals to 0, then return, else we are gonna do I think we have to initialize count at here, like count here, and every time we go for the 1, then we can increase the count plus plus. I think not. But we have to increase the value of count. Let's take it here. Then we can call the DFS for the DFS for direction. Like DFS will be I is -1, comma z grid n comma n. +1 -1 and +1. And this checks for the previous row. Like if we have it here, then this check for this position, and then +1 checks for the next down position, and j-1 checks for the left, and j+1 for check for right. If they get any, then we have to increase counter by 1 for all the PFS. But here we are no, we can't do that here. We have to initialize it here and give the value to 0, and here we can count plus comma count plus count plus okay. No. So last in the previous question, what we have done is that, if I am recalling correctly, that whenever we encounter a 1 at edges, means any anomaly, and just like at 1, then we what we did is we converted that into any other symbol. So I think it's a binary matrix, so we are able to change any other matrix. So what we have to do is that if we if we can travel from here and from any position, from these positions we can convert into any symbols like we did in last session. Then we test by using the for loop like this. I think this is gonna be a good solution. So what we have to done is that in this direction we don't know anymore. Count plus 1, we are starting from 0. If we found any DFS or DFS condition like 1, and here we have not like 1 and 1 and 1. If we encounter at the edge any of the edges, then what we do is that let's do this. It will increase by 1, and then we increase whenever this condition not satisfied, then we increase by 1, and then we check for any other BFS, then this will be, and we return here after all these values count, and here we also return count. I think so. Let's check. Oh, here we have hints. Let's return what what we are gonna return here is count as it is here. We have not given the count value. Okay, count no. Okay, please work. So what's saying here? Oh, So what? N and M. Work, brother, work. What? J. There is no J. Why do I do that? What? Oh, it's a runtime error. So any problem is running X. What? If oh, else if we are checking for the else if conditions, means we are not checking for the different one. This is a big mistake. So runtime error as well. So can you model this problem as a graph problem? Create n, 1 plus 1 nodes where n cross m nodes represent each cell of the map and one action node to represent the exterior of the map. In the map, add edges between neighbor and land cells and add edges between the exterior and land nodes which are in the boundary. Written as ensure the number of nodes that are not reachable from the exterior node. Oh, this is accepted. Create an m cross n plus 1 nodes where could represent each cell of the map and one section over to represent the exterior map. In the map, edges between neighbor and the land cells and add edges between the exterior and the land nodes which are in the boundary. Written as number of the why the runtime error? What I am doing wrong? Like here, okay. Oh, it started from I and Z. Okay, it's checking from out of the bound, but here we have condition with the 0. Row is out of the matrix. Less than 0 and I minus 1 j n comma n, y plus 1 j n m. That's your solution for all these problem like that. I j minus 1 j plus 1. We have checked it for the 0 j and the greater than equal to. Yes, we should be good. What's the problem here? Oh, so we are doing that we are checking for all these positions. Oh, we have did a big blunder. I have did a big blunder that I'm checked for all these conditions that these will be the path, but we have don't consider the path that are connected to the edges. Okay, so we have to give these we have to consider only these positions. So we have to do that convert all these edges that have 1 in the edges to 0, and after that count all the ones remains inside the grid that are not connected to edge. That's how we're gonna do that. So that will be a easy solution. But okay, so we have done. So okay, what we gonna do is that first remove the boundary connected land. So here for the first and last column grid equals to 0, then what we gonna do is that so we don't have to count that because we have to run a loop for the checking for this. That's why we don't need this. Here I have given m comma n. What? I have also done a mistake. N comma m. I have initialized n for the rows and m for the column. N comma m. And so now we are traversing these. And so what we're gonna do is that for the instead of increasing the count, what we're gonna do is that for the edges 1, that the position where the one lies at the edge, we convert that grid to 0. So 0 represent the seeds. So if we convert this 0, then all these are the inside the water, means the water seal. So now we can test all these condition. Now we don't need count. But we need loop for traversing from the row to column into 4 is equals to 0 m z plus plus, and we have initialized the count as 0, and now what we're gonna do is increase the counter if we encounter any one inside the grid. Count plus plus, and it will count. I think this would be good. Okay, yes, we have to remove these. This should be fine. Compile error. Oh, there is no need for we don't have to return void. That's we are gonna return, and we are not gonna return anything from here also. Okay, yes, accepted. Now test. I think this is fine. Okay, this is 9ms solution with 50%. So okay, let's rewrite the comments. I'm gonna revisit this question that helped me. First and last similar to data. Okay, here we can write that count for all the ones inside the grid. So let's write how. Okay, about that we're gonna, what we have done here is that first I travel. First I check for the so here is the approach, like that what we are gonna do is that I gonna do is I gonna traverse all the edges in the grid and any grid, any what we call a single column and any one in edge, any one on the boundary, then we will convert into 0 that represent 1, then represent C. Okay. Then we use graph traversal technique, DFS, to travel in all 4 direction for boundary 1, boundary where we find 1 to get all these, revert all the paths that are connected with C, connected with off boundary of, like anyone, anything like that. Okay, so that's the approach. Then point 3, point 2, point 1, point 3, run a loop on grid and the remaining loop remaining once in the grid are the paths that are not paths through which we cannot. Okay, so that's the language. We paths through which we can't walk of the boundary. Okay, that's the solution. Submit that. So what's the optimal solution? Like 1 ms. So this is, what is this? Yes, this is, yeah, similar. Mm. Yeah, this is a similar solution, nothing to be worried about. Okay, I think this is for this stream. This is a testing stream I have done, and I am here to I'm here to improve the my coding skills and also the communication skills. That's why I'm speaking for the entire stream for myself. Okay. Let's check the another problem. Word ladder. That's a little hard problem. I think this will be a tough problem. A transformation sequence from word, begin word to word, end word, using a dictionary. Word list is a sequence of words. Like I can stream for 1 hour more, but I have to stop speaking. Then that gonna be no way of find solution. I also take the solution for that. Surrounded region, number of enclaves in my notebook. Whatever then here is that. Check for the boundaries. So let's read this problem. Word ladder. Word ladder. What is this? A transformation sequence from word, begin word to word, end word, use a dictionary, word list. Okay, that a transformation. Wait a minute. I have to. What's the website to get pen for writing on a website? Epic pen. Okay. Start your free trial. Don't say it, so it. to have to log in. Epic Pen Pro free for 14 days. Then oh my god, Epic Pen free. Best alternative for Epic Pen. I use I was typing on every day for a while, but I just discovered that this app was making my stream run badly. All my screen apps geek dead. Let's forget about that. Which can Epic Pen can help him to write something that will help me in that screen. I don't have to draw here like opacity strokes like wow. A transformation sequence from the word begin word to end word using a dictionary word list is a sequence of words begin word such that every adjacent pair words. Oh my god, I can't read. So I think I should end this stream, and tomorrow I will be here. I'm doing this for my consistency because I procrastinate a lot and I am not very good at that. So what I'm gonna do is that I'm gonna stream and solve problems for the Leetcodes and learn, which can give me some motivation to consistently stream, and I guess it also helped me in my speaking. So that will be all for today, and let's see how it goes. Begin word hit and word cook, word list, what dog. So output file also transformation sequences. Transformation sequence from word begin word to end word using a dictionary. Word list is a sequence of words begin word such that every adjacent pair of words differs by a single letter. Every using the dictionary. Word list is a sequence of words begin word. Okay, so let's stop the stream. Thank you so much.